In the last few videos, we talked about PDO, MySQL, database transactions, and so on. We wrote some code, but now it's time to refactor this code so that our home controller, for example, does not do too many things. Right now, it connects to the database, so it's responsible for the database connection, then it runs some queries, creates user, invoice, and so on. So this at the moment looks pretty ugly and we need to refactor it. So let's get started. The first thing that we need to do is we need to look at our index.php, which is the entry point to the application. So I want to kind of extract this echo statement out of here and the try catch block. So we could create a class called app.php or application.php that will be responsible for bootstrapping and running our application. So what I want this code to look like is something like this. We have new app class, and then we have a method on it called something like run. And to make this more flexible, we could pass down the router object in the constructor arguments. This way, if we ever wanted to, we could pass another router. So we'll do router here, and we can now create this class. So I'm going to edit within the app namespace. We'll add the strict types here, and we're injecting the router into the constructor, and we can make this a protected property. Now we need the method here called run, which will simply resolve our routes. So we'll take this and we'll put it right here. We'll change this to this router, and then we need to wrap it within this try catch block here. So we'll do try and then add our handling here. Of course, you would add other kind of handling as well to catch other type of exceptions and not just the route not found exception. But for this case, this is enough. Going to import that. And because we are not using this, we can remove that. Now we'll switch back to the index.php and we can get rid of this try catch from here. We can also get rid of this resolve. And as you can see, we're simply left with the code to load the env file. We're left with some constants. We're creating a router object, and then we're passing that router down to the app instance. If we wanted to, we could also extract these routes out of here and put it into a separate file, but we're going to keep it simple for now. Now, if we switch over to the app PHP, we see that the run method is kind of depending on this server superglobal, and I don't want this to depend on the server superglobal at all. So we could pass that down within the constructor argument as well. We could accept some kind of request info here. So we'll do a request and we'll make this protected as well. And of course, we could implement a class if we wanted to, or we could use a third-party package that handles the requests and responses for us. But for now, I'm going to pass that down as an array. Now within here, we're going to remove this and replace this with this request URI and replace this with this request method. We can put this in the same line, and let's go to the index.php, and within here we can pass down the URI to be this and method to be request method. The next thing we need to do is that we need to have a database connection instance available across our application. Right now we have the database connection available within the home controller right here. But if we needed a database connection in another class or another method of the controller, we would need to duplicate this code, and essentially we would be creating multiple connections to the database, which is not good. So our goal right now is to have a single database connection, and the instance to that database connection needs to be available across the application. There are different ways we can achieve a single database connection. One, of course, is to use singleton pattern, which I'm not a fan of for the reasons stated earlier in the course. Another option is to use the dependency injection and pass the database connection through the constructor wherever it's needed, which is a good solution, but we haven't covered the dependency injection in more detail with dependency injection containers and so on. So we're not going to do that right now. Instead, we're going to make use of statics. Now, where can we extract this part of code? The obvious choice here is the app.php, because as I mentioned earlier, this is kind of our main class that starts our application. So we could store the single instance of the database within that app class. And of course, there are many other ways of doing it, but for now, we're going to put it within the app class. So I'm going to take this code, copy it, and put it within the app class, and we're going to put it within the constructor right here. Now we can create a static property here, something like private static PDO DB, and then we can assign that this way, and then we can create a getter method to access the DB instance. So we could create a static method called DB, which returns PDO instance, and we can return static db. Now within our home controller, we can get rid of this and simply put db equals app db. And this already looks a lot better. Now we have a single instance of the database connection, but we can do better. Let's go to app class again, and let's see what we can improve here. So right now we're accessing the env superglobal here, and for the same reason we decided to pass down the request info into the constructor, we'll pass down the database credentials within the constructor as well. So we can pass down some kind of config here. So we can do protected array config, and then we can simply replace all of these with the config array. We can also replace the MySQL driver here and use the value from the config. Now we can go to the index.php, and we could also pass down the config right here. So we can do host equals to env db host, and we'll do the same for the other parts. And for the driver, if the driver is not set, we'll use the MySQL as the default. Alright, so now this looks better. We're not accessing superglobals directly within our app class, but instead we're passing them through the constructor. Now we can improve this even better, and instead of using the PDO here directly, why don't we create a separate class that handles the PDO? So we would change this to be an instance of some sort of DB class, and then within here, instead of doing this, we would do static db equals to new db, and here we would pass in the configuration. So let's create this class within the app namespace as well, and we'll paste the code that instantiates the PDO instance right here. Now instead of static db, we're simply going to do this PDO equals to new PDO, and everything else remains the same, and we're going to add a new property here called PDO. Now also we may want to pass in some options, right? Because PDO accepts the options as another argument, so we may want to have some options saved in the configuration. So we'll accept options here, and if it's not set, we'll use some kind of default options. Now for default options, we'll say that our application must use the native prepares and not the emulated prepares, and we'll also use the fetch assoc as the default fetch mode. Alright, so now this looks good, but there are more things we need to do. So first let's switch over to app.php, and we need to change this return type from PDO to simply db, because we've changed it right here. And now if we go to the home controller, we see that now begin transaction and prepare methods are not available on the db object. That's because this is an instance of the db class, and db class does not have those methods. We're not extending PDO. If we were doing something like this, extends PDO, then this would work. If we go here, we have those available, but we're not using inheritance here. We're simply creating the PDO instance within the constructor. So one way would be to create a public getter method of the PDO and then use that method here to get the PDO instance. But another and better way is to simply proxy these calls to the PDO instance, and we can use PHP's magic call method for that. So we could do call, and within here we could simply proxy that call to the PDO object. So we'll do call user func array, and we'll use the PDO object and the method name, and we'll pass in the arguments as well. Now if we go to home controller, we see that it's still highlighting it, but it will work. This is highlighting because PHP Storm doesn't know that we're proxying these calls to the PDO class. What we can do is that we can simply add a mixin doc type here with the PDO, and now this should fix this issue. So essentially what's happening here is that when we call a method on the DB object that does not exist, it's going to trigger this magic call method. And because this method doesn't exist on this class, we're going to proxy that call to the PDO object and execute it on that PDO object, passing along the arguments. Let's switch over to the app class again. And just to note the static method here to get the instance of the DB and the static property, if we wanted to, we could move that within the DB class itself, and we could simply get the instance of the DB directly from there. In which case, instead of appdb, we would do DB and then change the DB method to instance method and so on. As I mentioned before, there are many ways of doing this, and later in the third section of the course, you will see how we can use something called dependency injection and dependency injection containers to avoid things like this. Alright, so let's switch over to the app.php, and I want to fix something else here. Right now we're passing config, and we're assuming that config only contains the database credentials. What if we had some other configuration values that we needed within the app class? We wouldn't want to add those as properties here, right? Instead, what if we simply replace this array config to something like a config class, and we implement this config class, and then we can do something like config db. Now, of course, the best way would be to make use of interfaces, but I don't want to make this video too long, so I'm going to stick with the regular classes for now. So what we need now is that within the index.php, instead of passing configuration like this, we need to pass in an instance of a config class. So we can simply take this and do new config, and within the constructor we can simply pass down the entire env superglobal. So this way we can have our config class be responsible to extract all the necessary data from the env superglobal as needed. So we're going to create this class, and we're going to add that within the app namespace as well. And here we're going to add a protected property called config and set it to an empty array by default. Now within the constructor we can simply assign the config to the proper values and replace the env superglobal with the env argument. So we'll do it this way, and we could of course add some validation here to ensure that the host, user, password, and database are set, and so on. And to make this more flexible, we can simply assign this whole arguments to a key called db, so that way we know that we have db credentials enclosed within this key right here. So if we had any other kind of configurations, we could simply put them right here. Now if we switch over to the app.php, we see that we're accessing them using object operator, right? And this property does not exist. We can use PHP's magic getter to make this work. So we'll switch over to the config.php again. We'll add the magic get method, and we could simply return the value from the config array if it exists, otherwise we'll return null. Now again, the PHP Storm does not know that this property exists, so we can use doc typing here to make the autocomplete work. So we'll add property read array db. Now if we switch to the app here, we see that now PHP Storm detects it, and to be sure we can add the null check here that if the db is not set for whatever reason, we'll pass in an empty array, so we don't get the type errors in the db constructor because this is expecting an array. Alright, so now I think we can test this out to make sure that everything is working before extracting these into models. So I'm going to change these to something else to make sure that we don't get the duplicate error exceptions. I'm going to open the browser, refresh the page, and sure enough we see that everything is working as expected, as it was working in the last lesson. So that means that the new classes that we created, which are the app class, the config class, and the db class, work as expected. Now one more thing I want to test before moving on is to make sure that we get the single instance. So we're going to access the db multiple times here, and let's simply var dump db1 triple equals to db2, and then db2 triple equals to db3, and db1 triple equals to db3. Now if any of this returns false, that means that we have more than one database connection. So let's refresh the page here, and sure enough we're getting true for all three cases, which means that these three variables db1, db2, and db3 point to the same object, and therefore we have a single db instance and the database connection. Well, of course, if you made a new instance of the app class or the db class directly, it would result in additional database connection. But you should not be creating instances like that directly. Instead, you should be using the db method on the app class that we created. Alright, let's move on to the models now. So based on this, we need at least two models, right? We need one for the user and we need one for the invoice. So I'm going to say that we need something like a user model. So we'll put user model equals new user, and then we want to execute some kind of create method on the user model which creates the user for us. So we can do user ID equals user model create, and we'll pass in the necessary information here. So we'll pass in the email, the name, the amount, and we'll also pass in whether it's active or inactive. So we'll pass in true for now. Next we need the invoice model, right? So we'll do invoice model equals new invoice, and we'll do the same thing here. Invoice ID equals to invoice model create, and here we'll pass in the amount and we'll pass in the user ID. Of course, if we had more variables, we would pass those down, or we could create something like a DTO to pass down a single object instead of passing down many arguments. And we'll talk about the DTOs in the third section of the series. Now this means that we could actually get rid of all these here. So let's create the user model first. I'm going to create this and we'll put it within the models namespace. And here we need the method called create, which accepts all of these arguments. So we need email, name, amount, and isActive. So I'm going to copy these here, and we'll set isActive to be true by default, which means that we can get rid of this from here. We'll set the type to Boolean, and we don't need the amount for the user creation. I don't know why I passed that in, so we don't need this at all from here. And we'll set this to a string. We'll set this to a string as well, and this will return an integer, which will be the ID of the user. Now we can take this simply and move it into the user model, and we'll replace this with a placeholder as well, and we'll execute the statement. So let's change that to statement as well, and we'll pass in the parameters. We can also take this part out, and let's get rid of this as well and move it right here, and we could simply return that. Now what we need here to make this work is the access to the DB instance. One way we can do that, of course, is by using app directly here, and this would work, but again, this is not ideal because we would be kind of duplicating this over and over in every single model. Instead, we could do something like this DB and have this be a property on the user model, or even better, have this property be on some kind of base model that all the models would extend from. So let's replace this with this DB as well, and we could extend some kind of model here. Of course, as I mentioned before, the dependency injection would be better, where we would take the DB connection within a constructor here and access it that way. But as I mentioned before, we're not going to do that in this lesson. So instead, we're going to create this base model, which is going to be within the app namespace, and we're going to make this abstract class. Let's also add the strict types here, and within the constructor here, we're going to simply set some kind of DB property to app DB. Now within our user model, we don't need the constructor, and we can access the DB property. Now it's underlining here because I set it to private. It should be protected instead. So if we go back here, now it's good. One more thing to note about this method is that if you were to call the create method within a loop where you were creating multiple users, you would be running this prepare statement every single time. To avoid that and prepare the statement only one time and then execute it multiple times within the loop, we could create another method called create many and pass down an array of users to be created, and simply prepare the statement before the loop and then run the execute within the loop. Now let's go back here and create a model for the invoice. So I'm going to create this within the models namespace, and we're actually going to copy the class from the user entirely and simply change this to invoice. And now we just need to change the parameters here. We'll change it to amount and user ID. Then we need to move this query right here and get rid of this, and this should work. Now you might be noticing that we are actually repeating some code here. We're running the insert query and returning the last insert ID, which is pretty similar to the create method on the user model. The differences really are just the table name, the arguments that we pass in, and the column names here. So if we wanted to, we could extract this and make it flexible and kind of create our own sort of query builder where we could reuse a lot of the functionality. But we're not building a query builder, and we're not building an entire framework here, so we're going to keep it simple and we're going to keep it as is. Now let's switch over to the home controller and let's get rid of this spacing here. And another thing that we need to fix is this query right here. Now this query we don't actually need, because the only purpose of this query from the last lesson was to confirm that the user and invoice were created, but we're going to confirm that in a different way. We can select an invoice by invoice ID. And also, just to note, I forgot to mention how you could do the wildcard search within the PDO when binding parameters. If you look at this query here, I've modified it where I'm using like instead of the equal sign, and then I use the placeholder instead of placing the ampersands directly in the query. The ampersands would go within the parameter that you pass, so you're kind of preparing the value beforehand. So we can get rid of this and get rid of this, and we can also get rid of this, and we could pass down some information to the view. So we could say that we're passing down an invoice, and we can find the invoice by using the invoice model and call find method, and because we have the invoice ID available, we can pass that to the find method. Now let's create the find method on the invoice model, and again we're going to use prepared statement here. To prepare, select invoices ID, amount, and full name from invoices, and we'll left join the users, and then we're going to do where invoices ID equals to placeholder, and we'll execute that query. pass in the invoice ID as the parameter. Now we can fetch the invoice using the fetch method, and as you remember, I set the default fetch mode to be the fetch assoc, which means that it's going to return as associative array. So then we're going to return the invoice if it's not false value, otherwise we'll return an empty array. This way we can type hint this to always return an array. Now let's go back to our home controller, and as you can see, our home controller actually looks a lot better. But we can actually do even better because there is something that I still don't like. We should extract this out of here as well. Controller should not be responsible for this. So we should move this within a model. Now the question is, to which model do we move this to? Do we move it to user model or do we move it to invoice model? It is up to you really, but I prefer to make a new model called user invoice or sign up, because essentially what we're trying to simulate here is a sign up, right? User fills out the form, signs up, and then we generate the invoice right away. So let's move these models out of the try catch block here because we don't really need them within there, and we need to move this entire code block out of this controller. So we can take this out and let's create a new model called sign up, and we can pass down the user and invoice models within the constructor. So we could pass in user model here and invoice model, and then call some kind of method, something like register. Within the register, we would need to pass in two sets of information. We need to pass in information for the user, and then we need to pass in the information for the invoice. So we could pass in two arrays, or we could pass in multiple arguments. It's really up to you how you would want to pass that in. So we'll pass in email and name here, and then within here we'll simply pass in amount. Now we could actually get rid of this DB instance from here, and we can have the register method return user ID and invoice ID, or we could let it return just the invoice ID, or we could have it return user object or invoice object, and so on. So we'll say that this returns invoice ID, and let's create this model. And within the constructor, as I mentioned, we're accepting user and invoice models, and we'll turn these into properties, and then we'll add a method here called register, and we're accepting user info and invoice info, and it returns integer, and we can paste in this code here, and we can extend the base model here, and we need to call the parent construct here to make sure that it sets the DB property here, and then we can replace the DB variable with this DB and replace user and invoice models with this invoice and user model. Then we'll change the email and name to be coming from the user info variable, and we'll change the amount to be coming from the invoice info. And finally, we'll return the invoice ID. And our controller now looks a lot cleaner. Now the final thing that we need to do is we need to actually display something within our view. So let's open the index view, and within here we're going to simply add a horizontal line and say if the invoice variable is given, display the invoice ID with the break line, display the invoice amount, and display the user full name. And of course we need to escape these, otherwise you will be vulnerable to XSS attacks, and we're going to talk about XSS attacks in the third section of the series, along with the security topic and other attacks. So don't worry about it now, just know that the data you display to the screen needs to be escaped, otherwise you might be vulnerable to XSS attacks. We're going to use HTML special cars here to avoid that, but there can be other types of XSS attacks, and we'll talk about those in the third section of the course. Now let's actually test this out. Let's refresh the page, and we're going to get this duplicate error because this user already exists. So let's change this to something else and refresh the page, and sure enough we get the invoice ID, the invoice amount, and the user. So this is it for this video. Thank you so much for watching. Please give this video a thumbs up if you enjoyed it, share and subscribe, and I'll see you next time.